All right. Helping you some more with that phasing assignment. Really trying to understand it here a bit better. So, there's a couple ways I've seen it done here, like on the answer key is a little bit different than what I taught. So I taught you take a regular sine of x minus pi. You take regular sine of x right there, and you identify the different parts to it. So you identify, so for example, the amp is 2, midline is 0 because nothing's there. Awesome, amp is 2. And then the period is 2 pi over b, where our b is just 1. Cool, 2 pi. So kind of updating my answer key here just to see what we got so far from about 5 years ago. And then trying to make it, I don't know, easier to grade. Especially for Mr. Merkley. Yo, name drop. He's helping me out. Thanks, Parker. Okay, so let's see here. So starting off, we would use sine. And let's see here. So our original sine function would go up to 2. So I guess we're going to label this as 2 and negative 2. So it would go up to 2 because it's just going to 2 pi. Like that. And then it'd go down to pi. And then it would finish off at 2 pi. Cool. And then what we're trying to show there is that our phase shift, which is pi, comes from this guy. And so you have to change the sign. So instead of being a negative pi, it's a positive pi. And then you divide by b. Cool. And so our b is just equal to 1, so it's just pi. So then we go ahead with that dotted line, and we go ahead and shift it. Looks like what we've done here, which is awesome. Kind of match up the color there. So we shifted, so instead of starting here, we're actually going to start here at pi, because we've shifted over the whole graph. So then you can see here, our answer is starting at pi and finishing at 3 pi. Cool. So there's our phase shift, moving the thing over a whole pi, plus 1 to the right pi. Cool. So then, awesome possum. So then looking at some of the other ones, just to look at a couple harder ones there. So for example, number 12, let's take a look at that guy. Or maybe number 10. 10's not too bad. Have we done 10? Can't remember. We've tried lots of different ones in lots of different classes. I don't think I've done 12 yet, though. So number 12, we have a midline of plus 0. Nice. Because there's nothing there. In fact, that's most of them. I think that just made it easier on this assignment, is having a midline of 0. So it just means there's nothing plus or minus over to the right there for the k value. Awesome. Okay, so then, ooh, interesting with 12. So with 12, we do have an amplitude of 1/2, which is going to go ahead and make it narrower. Narrower. And so that comes from here. That's our amplitude. And then our period, 12 doesn't even look like his phase shift. So the period is, the b value is just 1/2. So 2 pi over b, where our b is just 1/2, so that's just going to be 4 pi. Wow, I'll let you finish that one. So that doesn't have a phase shift in it at all. What? Yeah, none. So that's just a standard one, so let's do a different one there. It's number 12. Let's see, what about number 6? 6 looks pretty cool to do. So we can see that phase shift there. Let's see, let's try to do maybe a harder one. I remember doing 10 and 11 were pretty tricky there, and then we'll look at the answer key. So for number 11, we went ahead and need to distribute the 2 through. So we end up with negative 3 cosine, and then that's going to be 2x, because 2 times x is 2x. And then 2 times pi over 2 is going to be 2 pi over 2, where the 2's cancel. So our amplitude is 3. It's not negative. It's always positive. And then that negative symbol just means upside down. So we're going to go ahead and graph upside down for our cosine function there. Awesome. There's no midline, just plus 0 for our midline. Now the period is going to be 2 pi over b, and that b value is important because the period is going to use it as well as the phase shift is going to use that b value. So super important. So our b value is 2. That's important. So for the period, it's just 2 pi over 2, 2 pi over b. So the 2's cancel, just leaving us with pi. That's our period. And then the phase shift is going to be this guy, opposite sign. So instead of a positive pi, it's a negative pi. But it is going to be a negative pi over b, over our b value 2. So negative pi over 2 is our phase shift. Cool. So what I think I've seen on the answer key, we'll double check in a second, is I think they went ahead and thought, well, let's not show the parent function and the shift because that might be too much. Let's just go ahead and do the period. And then minus the phase shift. And then that'll just give us equals, so period minus phase shift gives us just a new phased period, right? So we just have a new period, and that'll be our answer for our graph, right? So our period is pi minus our phase shift, which is or maybe minus, maybe plus. Let's take a look. So originally it was plus, so it is going to be minus now. So it could be at our phase shift because that means shift to the right. We'll go backwards now. Ooh, backwards. What does that mean? Ooh, interesting. So backward means we're actually going to go to the left. Cool. So that means we're actually going to, let's see, if our phase shift is pi, then we're going to go to the left, pi over 2. Nice. Let's see here. So if we're going left, pi over 2, so we are at the period pi and we're going to go left, what would that be? That would be kind of minusing it. What would that be? Confusing myself in my head right now. So if our period is pi, then we're going to go backwards, right? And so that means if we're at 0, then we're going to go backwards. We're going to minus pi over 2. And we're going to get a negative pi over 2 instead of 0. And then if it's pi, we're going to go backwards. So we'll minus pi over 2 and get a positive. So pi will become a pi over 2. Interesting. Okay, so this is kind of like our, should switch those around really. My mind was kind of just working it out there. Okay, so 0 is going to become negative pi over 2. And then our pi is going to become pi over 2. Cool. So that's going to be our kind of phase shift thing there for our cosine upside down. So we're going to start basically at negative pi over 2 like this. And then we'll go to pi over 2 like this. And that'll be kind of our new phase shifted beginning and ending point just for the phase shift graph. It is going to be negative. It is going to be upside down. It is going to be expanding 3. So now we're going to start at negative pi over 2. We're going to go upside down. That's it. And then our middle point will be here at positive 3 and then back to 3. Because it is upside down and expanded a distance of 3, right? Expanded a distance of 3, and it is upside down. So there we go. That's our new phase shift graph. So let's go and double check. It's not really showing the parent. That's just kind of jumping to the phase shifting part. So we'll take a look there at 11. Awesome. So yeah, cool. So that looks right to me. So I just need to do some labeling, it looks like. So negative pi over 2, and then positive pi over 2. Cool. And this goes up to 3, and this goes down to negative 3. So it looks like I'm going to stop this video here in a second to do lots of labeling because our answer key doesn't look like there's lots of labeling been done. What? So we'll do that real quick and ready for our answer key for next time. So thanks for watching and trying to understand this phase shifting, how it works. You can also do the parent function and then move backwards or forwards. I taught that as well to you. So thanks for watching both. Appreciate you. Thanks for watching. Bye for now.